Hey guys, welcome to Simplifysics. In this video, we will be learning the lens formula, magnification and power. So let's have a look at image formation by a convex lens. Here the image is beyond 2f, inverted, magnified and real. But what if we knew that the focal length was 10 centimeters and the object was placed 15 centimeters away from the lens? The question that would arise is, how far is the image formed? Yes, the image is magnified, but how magnified the image is? Is there a way to find out? Let's find out. If f is the focal length, u is the object distance and v is the image distance, we would find that these three quantities are related to each other by the formula 1 upon f equals to 1 upon v minus 1 upon u, which is also called the lens formula. I'm not going to prove this formula over here because the proof is not there in your syllabus. Also, our intuition would say that magnification would be the ratio of image height to the object height. So if hi is the image height and ho is the object height, then the magnification m would be equal to hi upon ho, and we could also prove that this is equal to v upon u. So both these formula are very useful, but in order to use them we need to follow certain sign conventions. So if we place a Cartesian grid on top of this lens, up is positive, down is negative, right is positive and left is negative, we would discover that the object distance is always negative, whereas the focal length and the image distance are always positive for a convex lens. Also, the image height would be negative in this case and the object height would be positive in this case. For a concave lens, we would discover that the focal length, object distance and image distance are all negative because they are on the left of the lens. So let's use both these formula to solve a problem. Here, the focal length is 10 centimeters, positive because it's a convex lens. The object distance is 15 centimeters, negative because it is placed towards the left of the lens. And we would first find the image distance v. So the formula that we would use is 1 upon v minus 1 upon u equals to 1 upon f. Simplified, this would become fu upon f plus u, and when we replace values we find that v equals 30 centimeters. What does this mean? This means that this is a positive value, so the image would be 30 centimeters towards the right of the lens. Now let's find the magnification. When we replace values we find that the magnification is -2. Now what does this mean? It means that the image is twice as large as the object. Also, since it's a negative value, it would mean that the image is inverted, and since inverted images are always real, it would also mean that the image is real. So this value of magnification tells a lot about the image. For example, it tells us that if the value is between 1 and -1, the image is diminished. For all other values, the image is magnified. Also, if the value is positive, it means that the image is erect, and if the value is negative, it means that the image is inverted. Now, since erect images are always virtual and inverted images are always real, it holds true for the type of image as well. So now there are two ways of describing a lens. One is the focal length and the second is its magnification. But there's also a third way of describing a lens. So to understand that, consider lens A and lens B. Lens A deviates a ray of light by a greater amount compared to lens B. So we'd say that lens A is more powerful and lens B is less powerful. So here's how we can describe a lens. We could describe a lens in terms of its power. And the power of a lens would be the ability of a lens to deviate a ray of light. Lens A is able to deviate a ray of light by a greater amount. It's more powerful because it has a lesser focal length compared to lens B. So the power of a lens is quantitatively equal to 1 upon focal length. P equals to 1 upon F. And if the SI unit of focal length is meter, the SI unit of power would be diopter. So how can we calculate the power of a lens? Here's a convex lens of focal length 10 centimeters, and if we express the focal length in meters, the power of this lens would be positive 10D. If we have a concave lens of focal length minus 20 centimeters, and if we express the focal length in meters, the power of the concave lens would be minus 5D. And if we were to find the power of this combination, the power of the combination would be the sum of the powers of the individual lenses, and in this case that would amount to positive 5D. So now we have three ways of describing a lens. One is focal length, second is magnification, and the third is power. And now the summary of this video. The lens formula expresses the relationship between focal length, object distance, and the image distance. 1 upon f equals to 1 upon v minus 1 upon u. The ratio of image height to object height is called magnification. And the value of magnification helps us state the size, orientation, and type of the image. The reciprocal of focal length is called power of a lens, which is always positive for a convex lens and negative for a concave lens. So that's all in this video. In the next video, we will be starting a new chapter, spectrum and electromagnetic waves.